Right. So we're going to look at quadratic real world applications, and we've got a couple of different things we're going to look at, different types of problems. And so first off, we've got to learn how to set up the problem. So I'm going to look at this situation. Steve has 120 feet of fence to make a rectangular kennel for his dogs. He uses his house as one side, so he's going to do a fence around the other sides. Write an algebraic expression for the kennel's length. So you got 120 total. You got 120 total. Okay. And then minus two, like 120 total, and then you've got minus two sides to be x, okay? So you got 120 total here for these three, and to get this dimension, you're basically, it's 120 the total minus the length of these two sides. So this would be 120 minus 2x, okay? What dimensions will produce the greatest area? Well, first off, we have to find a function for the area. So I'm going to call the area function a sub x equals length times width. One of the dimensions is x. The other one is 120 minus 2x. So I've got to find a function for this. So I got to find a function for the area. Okay. Kind of a lot of layers to this. I'm throwing a lot at you here. I'm going to distribute now. 120x minus 2x squared. And I'm going to rewrite this in standard form where I put the leading coefficient first and then this in order. Okay, so there's my area function. Now, this is what we call a maximizing problem. Okay, this is called a maximizing problem. Okay, so I'm maximizing. And so when I'm maximizing, I'm going to use the formula that we learned about in the first lesson, actually, the axis symmetry formula. I'm going to find that value that maximizes it. So I'm maximizing, I'm going to use this formula. That's going to be important. So I'm maximizing, I'm using this formula right here. Okay. So A equals -2, B equals 120. So X equals negative B, which would be -120 divided by 2a. So this will tell us the value of x that would maximize this, the area for this kennel. So -120 divided by -4, x equals 30. So 30 is going to be 30 feet will be my value of x. So that'll be one dimension. Now the other dimension, so that's this dimension. What's the other dimension going to be? The length is going to be 120. That's 2 times 30. It's 120 minus 60. So it'd be 160. So 60 feet. So it'd be at 30 feet by 60 feet. Okay. Put a boxes here. Now I've got to find what's the maximum area. Well, it's a 30 by 60 feet. So this is pretty simple. 30. And so this will kind of go, I'm actually going to draw a barrier around that. All right. 30 by 60. It's 180. So it'd be 180 feet squared. Okay. So that'd be your math.